Welcome dear friends. In this tutorial I want to prove the formula of integration method and also work an example in this tutorial. By integration method we select a beam with the length of unknown x and also a variable load w unknown. When we take section from this part and this part of dx, three unknown internal force created here and three unknown internal force created here. So we call the V shear force and N normal force and M bending moment. Also in this part also the same, but it's a little different because when we cross from this point to this point, or come from this point to this point, the V changed to V plus dV and M changed to M plus dm because this W act in this length of dx. Now I want to prove the necessary formula. We use the three static equation as we studied previous. So we can write a summation of if y along to y direction equal to 0 and upward we accepted positive. We can write v minus of w multiplied by dx and minus of v minus of dv equal to 0. This positive and negative v finished, and we carried dv the other side of the equation, so dv equal to minus of w multiplied by its length dx. We divide both sides of the equation by dx, then this equation, or the first equation corrected, dy of dx equal to minus of w. It expresses or shows the derivative of shear along to x direction equal to minus of w. And also we change the position of dx dy dv equal to minus of w multiplied by dx. We take integral from both sides of the equation, definite integral, so integral a to b dv equal to minus of integral a to b w multiplied by dx. As you know, the theory of differential and integral, and that integral and differential remove each other, so this part remain v from a to b, and this side minus of w multiplied by integral of dx change to x from a to b. And then we, according to the integral definite integral, we can write v b minus of v a equal to minus of w. We put upper side and downward side subtract in here, b minus of a. Then we change this index that vb equal to v right and va called v left. This side is the same. We change the position of VAL to the other side, the sign change to positive. V right equal to minus of W multiplied by its length, B minus of A plus V left. This is the second equation, and it's very important for using or calculation of shear force. And the usage will be studied then in our example we have in this tutorial. And also now we want to prove the formula of moment. We take moment at the point of O1 in this section O1. When we take moment, we accept counterclockwise positive and clockwise negative. M act clockwise negative, and we also act when we take moment at the point of O1 also negative, and W also M plus dm act the counterclockwise, it is positive. So we can write here summation of moment at the point of O1 equal to 0 minus of m, this m, and minus of v multiplied by this arm, v multiplied by this arm dx, plus w, this w distribution load, multiplied by this length, multiplied by dx, and multiplied by this arm, dx of 2 or half of the x, dx, plus m and plus dm. M and dm act counterclockwise, it's positive, equal to 0. This minus m but the plus m finished, and we can write dm minus of v multiplied by dx plus w, and dx multiplied by dx change to dx x square according to the infinite small function that there is equal to 0, but this part remain. We change the position of this part to the other side of the equation, and sign change to positive. So we divide both sides of the equation by dx, dm of dx equal to v. It's the third equation, and it shows that the derivative of moment along to x direction equal to the shear. And then we change the position of dx, dm equal to v multiplied by dx, and we take into definite integral from both sides of the equation. Integral a to b dm equal to integral a to b v dx. Then integral and differential remove each other. It remain m from a to b equal to v multiplied by x a to b, then v. According to a definite integral, we can write m minus of mb minus of ma equal to v multiplied by its b minus a. Then we change the this index ma right minus of ma left equal to this part the same, but we change the position of m left to the other side of the equation, and the sign change to positive. M right or moment of the right side equal to v or shear multiplied by this length plus the moment of left. It's called the second the fourth equation, and it's actually the formula of calculation of moment by the integration method. It's very important, you should remember all the time. It is very useful and benefit for finding of internal force, especially for moment. Now we want to use this formula and calculate the internal force and draw the internal diagram of a beam deer. So we choose as an example this beam at the length of 10 meters. Two load act on it, one distributing load and one joint load or point load. First of all, we find the reaction of this beam. For finding of its reaction, it is the same as a section method as we said in the previous lecture. Now I want to find the reaction. We take moment from the A, and the counterclockwise accept positive equal to 0. And then we can write minus of 10 multiplied by this arm 2, and minus of 4 multiplied by its length 6, and multiplied by its arm 4 plus half of the 6 3 plus dy multiplied by its length equal to 0. Then we find the dy and after calculation equal to 18.8. Then we use the second equation, summation of f y along to y direction equal to 0. Ay, the upper side we accept positive generally, minus of 10 kilonewton, and minus of 4 multiplied by its length 6 plus dy equal to 0. Then ay equal to 4 multiplied by 6 24 plus 10 34. We change the other side, it's positive, and we put also we change the position of dy to the other side of the equation. Put it is value or its price 18.8 after subtract equal to 15.2 kilonewton. It's the reaction of ay. Now we use this formula for finding of internal force. Okay, we do it directly by calculator find internal force and draw the diagram. How? Oh, there is 15.2 kilonewton the reaction. We draw a line along to y direction about 15.2. We calculated before this to there. Then there is no load. We draw a horizontal line up to 10 kilonewton joint load. After we subtract from this line because the direction is opposite of each other, and we can write 15.2 minus of 10 kilonewton equal to 5.2. Okay, we have find 5.2. Then we draw a horizontal line up to this point or the start point of distributing load, and then we subtract the area the act distributing load 4 multiply plus its length 6 equal to 24. Then we subtract from this 24 minus of 24 equal to minus of 18.8. This point obtained. We draw a line and connect these 2 points, and but this line is inclined because our load is distribution load, and it draw the shear force diagram, the scale of kilonewton. Now we draw the moment diagram. From this formula we use integration method. We start from the left this point there is no moment, it's 0, and then we find the area of this rectangular 15.2 multiplied by its length 2 equal to 30.4. This point find. Then we find the area of this triangular 5.2 multiplied by its length by 2 equal to 10.4 plus the left moment 30.4 is 40.8. This moment obtained. Then we find the area of this triangular. How we find the area of this triangular? We use the properties of proportion. As you know that smaller triangular line is a proportion, so we call this line equal to x of 0.52 equal to 6, this line of 18.8 plus the height of this triangular 5.2 is 24. There is 24. Sorry, there is written little. This problem is incorrect. It's actually 24. Then we will find the value of x. X equal to 1.3 meters. There is 1.3 meters. And now we find the area of this triangular. According to the formula of area of triangular, 1 of 2 or half, 0.5 multiplied by its length 1.3, and multiply by this height 5.2 equal to 3.38 plus the left moment 40.8. It's the maximum moment is this point. When we calculate the area of this triangular, it's minus. It must be the also the negative or minus of 44.8, because the summation of moment must be 0 from this point. When we find the area of this triangular, 0.5 multiplied by its height 18.8 multiplied by its length, it is the total is 6. When we subtract 1.3 equal 4 multiplied by 4.7, actually 44.18. It's negative and it's positive. That's total or summation of them or 0. So it shows that our example is correct, because when we start from the 0 point and end, the curve must be closed, finish to 0. It is the end of this tutorial. Thank you.